Welcome to Pomodoro Joe for Friday, July 14th, 2023. Today we're doing LeetCode problem 1218, longest arithmetic subsequence of given difference. This is a medium problem. All right, so we're given an integer array, r, and an integer, difference. We need to return the length of the longest subsequence in r, which is an arithmetic sequence, such that the difference between the adjacent elements in the subsequence equals to difference. All right, a subsequence is a sequence that can be derived from R by deleting some or no elements without changing the order of the remaining elements. All right, and then we have some examples. So we have example 1, where we have 1, 2, 3, 4 with a difference of 1. So we can just return 1, 2, 3, 4, or output 4. There are 4 elements. Example 2, 1, 3, 5, 7 with a difference of 1. Well, it looks like none of these are a difference of 1. So we can choose just one element, and that will be our longest subsequence. So we return 1. All right, now 1, 5, 7, 8, 5, 3, 4, 2, 1, difference of negative 2. So we have to look for elements that are different by negative 2. So it looks like the one that we have here is 7 to 5 to 3 to 1. 7, 5, 3, 1, and that's output 4. Okay. So we will put 25 minutes on the Pomodoro timer and we will get started. Now for this, we need to return an integer value so we can have some result. Now we know we have at least 1 because we can choose any individual value, and that could be a sequence of length 1. Actually, let's make sure. Yes, the array will at least have 1 element in it. So our result will default to 1. And at the end, we will return our result. All right, so for this one, I think it's super tempting to say, well, we just start at index 0. We'll grab index 0 and find the longest sequence we can make from index 0 to the end. So we can do something like for every start index in range length of array, and then we'll grab that start index, and then we'll go for every other index, for every end index, range length. So we could go down this route. But if we did this, we would have every start index going to every end index. So that's going to be an O of n squared algorithm, because for every number in our array, we have to go through every other number in the array to see if this makes a longer subsequence. So that's an O of n squared algorithm. Now, we don't really want to do that. Let's see if we can find a better way. Now, I wish I had a way to describe how to derive this. Basically, I've done this type of problem before, so I kind of know how to do this problem. So my advice is just practice these types of subsequence problems. Once you do a bunch of subsequence problems, you kind of get the patterns. So one of the subsequence patterns is, instead of looking at this element as the start of the array or the start of our subsequence, let's take every element and consider it maybe the end of a subsequence. What if we said, start at this 1 and say, how many sequences can end at this 1 with a difference of negative 2? Then we move on to the next element. How many subsequences can end with 5 with a difference of negative 2? Then move to the next one. How many can end at 7? How many can end at 8? So if we keep going through this one at a time, that's an O of n algorithm. So we'll do something like for every I in our array, or maybe for every n, for every number in our array. How many subsequences can end at this number? Now, the advantage of doing it this way, considering n the last element in our subsequence, that means that we've already processed all of the elements that led up to this n. So if we're ending our sequence at this element n, all we have to do is look back to see what was the longest subsequence that ended at this difference. Maybe that makes sense. Hopefully that makes sense. So if we want to find out what's the longest subsequence that ends at this n, we really want to find out what's the longest subsequence that we've already found that ends at n minus this difference. So let's have some dynamic programming here. This DP will be a default dictionary of integers. All right, and I'll do a little note here. So our key, so the key is the previous element value. I'll call it that, previous end value. And the value here, that will be the longest subsequence that ended at that value. So this might be a little confusing, but this DP is a dictionary where the key is some element that will be the last element of some subsequence, and the value will just be the length of the subsequence that ended at that element. All right, so now we have this DP, and we know what it's going to hold. It doesn't currently have anything in it, but we'll be building it up as we go through our array. So for every element in the array, if we're considering this the end element, what was the previous element value? So we call that previous n. Well, that's going to be this n minus the difference, because that had to be the last element before we get to this element. So now we just look up the longest subsequence that ended on that previous n. So longest subsequence ending on n, or let's just do it this way. So the previous subsequence length, actually let me do it this way. That's just this dp for this previous n. So what was the longest subsequence that ended on this previous n? So we can look that up in our dictionary. All right. Now, what's our current n going to be then? Well, the dp then for this element will just be this previous length plus 1, because we're adding this element to the end of that previous subsequence. And then we can check to see if our result is better or worse than this current dp. So we can just check our result here. So our result will just be the max of either our current result or this new subsequence length. All right, and that should do it. So about 15 lines of code, not too bad. So we start our result at 1, then we'll return our result at the end. Now in between, we will go through every element in our array, considering that as the last element in some subsequence. Now, if it's the last element in some subsequence, what was the previous element? So we find the previous element by taking this element's value, subtracting the difference, and that gives us the previous element's value. Now, once we have the previous element's value, we can look up that value's longest subsequence in our DP. So we check out what was the longest subsequence that ended at that value. If we have one, it'll be some value. If we don't have one, this will be 0, because we're using a default dictionary. Now, we can take that subsequence length and add 1 to it, because we're adding this new element, this n, as the last element in that previous subsequence. Next, we check to see if that result is better than our current result. And if it is, then we replace our result with that new result. All right, let's see if this works. Okay, so this works. Let's submit this and see how we do. And we pass. And we have some new interface here. Interesting. So we don't do great. We only beat 29% for runtime, 62% for memory. So let's jump back and clean this up a little bit. So a couple things we could do. We don't actually need this separate previous n. We could just grab this. Let's just do this here. All right, so we're just replacing our previous n directly in our lookup. We also don't need this previous subsequence because we're only using it here. So we can grab this whole thing, put it here. All right, so that's going to clean things up quite a bit. Look at that. Let's check this out, see if it works. Still works. Let's submit that, see if we do any better. Yeah, we're doing a lot better. That's a 58% for runtime and a 92% for memory, so much better in our memory. All right, and we can do one quick thing to improve our runtime. We can do our own max calculation here. So we'll just say result is result if the result is greater than this dp of n, else dp of n. Okay, so let's see if that helps. That gets us up to a 74% for runtime and a 62% for memory. Not too bad. All right, I think that's it for me. So the key to this one is to go through and think of every element as the last element in the subsequence. That's sort of the key takeaway from this. When you run into a problem with subsequences and you look for the longest subsequence, always consider the element as potentially being the last element of the subsequence. That should definitely help you out. All right, that's it for me. Hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.